should look something like that. So a little bit of information about our job scheduling system. I mentioned earlier when I was talking about running jobs on a cluster that you'll log into the user node and you'll submit your job scripts by sending them to the Pbs job scheduler, to the job scheduling system. Our job scheduler is a Pbs job scheduler. It's Portable Batch System Job Scheduler. There are lots of different types, and that's just the particular type of scheduler that we use. The job scheduling system that we currently use is Pbs Professional version 12. And what this system does is it allows you to write job scripts that define everything that you need to run your job. You can, in those job scripts, you can explain what hardware you need to run, and as well as all the commands you need to run your simulation or your calculation or whatever your data processing tasks, whatever you're doing, would all be contained in your job script. And then you submit that to the Pbs job scheduling system. And the job scheduling system will take a look at what hardware you require. And first of all, it'll see if the hardware you're specifying, if your requirements even make sense. If your requirements do make sense, then the job scheduling system will look to see if the hardware you need is available. If it's not, your job will just wait in the queue until the hardware you need becomes available. If the hardware you need is available, if you're not asking for much, if you're not asking for a lot of memory, if you're not asking for a lot of nodes, then your job will typically start pretty quickly. And the scheduler does a lot of other activities, primarily involving policy enforcement for the most part, making sure that all users are using the system fairly. And our system administration team has worked for many years to tune our job scheduling system so that it works as efficiently as possible and as fairly as possible. It's actually a very difficult task to manage one of these systems, and ours is quite complicated because we have this large heterogeneous cluster and we have a large number of users. So we're constantly tuning this system to work better and better, and it's just a never-ending process. But that's the system that we use to manage jobs. The way you interact with the job scheduling system is typically through the qsub command, and there are a few other commands that you'll use. The qsub command is what you'll use to submit a job to the scheduler. And so you'll create a job script, and then you'll use qsub to send that script to the Pbs system. And then the Pbs system will accept it, assign a job ID number, and possibly start the job running. And that's considered a batch job. That process of submitting your job script and letting the scheduling system run your job kind of in the background without your hands-on interference, that's running a batch job. However, there's another type of job you can run, and that's an interactive job. An interactive job is run by executing qsub followed by -I, and then you specify the hardware resources and other aspects of your job. An interactive job involves being actively connected to one of the compute nodes. And so any computational work you do while you're logged in there is going to take place only on that compute node. And so that's a really good place for debugging purposes, testing your code. You can set up a parallel environment with multiple nodes in an interactive job. So you can test parallel code and do a lot of really useful testing and evaluation work in an interactive job. So it's a good idea to test your job in an interactive session before actually submitting a batch job to run over the weekend. Other commands that you use to interact with this job scheduler are the qstat command, which will list, the qstat command by itself will list all the jobs that are currently running. Let me show you what that looks like. If I run qstat, I get this huge list of all these jobs that are either running or waiting in the job queue. See a lot of these jobs here with the queue in this column over here, those are all waiting in the queue. These other jobs with the R are actually running already. But that's for all users, and that's not very useful to me. What I want is the jobs that only I am running. So if you run qstat with the -U option followed by your user ID, then you'll see the status of only the jobs you are running. If you need to terminate a job, if it's waiting in the queue and you want to go ahead and kill it and maybe change the hardware requirements or something like that, then you can use the qdel command followed by the job ID number. If we look in this list, you can see that all these jobs have a job ID number. It's that 7-digit number at the beginning there. That's the PBS job ID number. And that's what you can use to terminate a job. Additionally, if you have lots of jobs that you want to terminate or manage in other ways, you can use the qselect command, and there's a variety of criteria you can use to get a list of job ID numbers for specific jobs. The details for using the qselect command are available in the Pbs User's Guide. And let me show you where that is really quickly. Of course, we have the Palmetto User's Guide, which is just a general purpose guide for all kinds of things that you need to know about using the Palmetto cluster. But if you need to look at specific PBS commands and advanced options for using the PBS system, we have the Pbs User's Guide, as well as the Reference Guide and the Administrator's Guide, all available at the top of the Palmetto User's Guide. If I want to look at the Pbs Professional User's Guide, just click on it, and it opens up the PDF version of that guide. And this is a really long guide. But if we look at page, I think it was page 60. Here we go. It's on page 62. These are all the different job submission options you have. Most users only use 1 or 2 of these options. But just be aware that there's this very long list of options available for you to use in the Pbs User's Guide, starting on page 62. So that's the Pbs User's Guide. Anyway, those are the basic commands that you'll typically be using for interacting with the job scheduling system. All right, so if you've copied that directory and you're ready to start running jobs, you can go ahead and submit an example job right now. And this slide just presents one of a bunch of different example jobs that I have available for you to use. Let me just take a look at those really quickly. So in that intro.palmetto directory, I've got a directory there called examples. CD to examples. And there you'll see a lot of different examples for different applications. We've got parallel examples. We've got examples that use local scratch, that is the local hard drives, as opposed to the large shared file system. I've got different versions of this LAMPS molecular dynamics package, both double precision and single precision examples. I've got a very simple example of running R. Let's take a look at this example called lamps.dp. That's for double precision example. And that's the one I'm talking about in this slide. This is LAMPS is a molecular dynamics simulation program. And this simulation is just a quick cooling of a binary mixture of 2 different types of atoms. And it's cooling from about 700 Kelvin to 200 Kelvin over the course of about 50,000 steps. And, I'm going to launch that job. Let's take a look at the Pbs job script. The data needed for my job is right there. The input file for my program is right there. And the job script itself is this file that ends with .pbs. You can name your job scripts anything you want. I just use .pbs as a convention. So I'm going to use cat to look at the contents of that file. And that's it. That's the entire job script.